Okay, we in intermediate class this afternoon or this evening, we went through the sawhorse exercise in the handout. Here's the handouts for it. I've been meaning to update this or redo this for a while, so you might want to stop and get yourself a copy of this. I'll refer back to it off and on. But, again, I need to redo it. It's kind of advanced for this stage in what the class is learning. Anyway, I'm going to start I'll start with follow it 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll try to do it in the steps shown in the order from top upper left to lower right. Let me start a brand new start from scratch drawing. I've today, I think part of the confusion was this 45-degree polar tracking angle with a isometric viewpoint. The z-axis perfectly lines up with the 45-degree polar tracking line on the XY plane. So I'm going to change it back to 90 to avoid that confusion. So again, I'm going to set polar tracking to 90. As always, I'm going to recommend my 5 favorite O snaps: endpoint, midpoint, center, quadrant, and intersection. Never have tangent, perpendicular, or nearest running. Nearest might be handy for short-term use, but always, always, always set it back to these 5 object snaps. And I don't think you'll ever have any regrets. Here's a brand new start from scratch drawing. The first step is to adjust your view as shown, but don't get a pure isometric, because the z-axis might line up with a 45-degree polar tracking if you didn't think to change it to 90 as I just did. So try to get approximately a southwest isometric using the 3D free orbit icon, but not perfectly southwest isometric, because you don't want the z-axis pointing straight up. So I just reviewed the model. A 36-inch long 2x4 on edge is shown. Remember, the real 2x4 dimensions are 1.5 by 3 1/4, 1.5 by 3.5 inches. Keep your cursor pointed in the X direction to be sure that the length of the board is perfectly in the X direction. It's easy mistake to make if you don't watch your cursor. Your board may be skewed, and make everything else harder from here on. Next step is to copy the board straight up so the top surface of the board is at 36 inches. We'll take the bottom board and stretch it out to be a 48-inch board. Let's go back to brand new start from scratch drawing. I'll go to the navigation nav bar, I think it's called, free orbit, and I'll rotate it so it's approximately a southwest isometric, but I'm going to go out of my way to make sure the z-axis is not pointing straight up. We'll hit escape to get out of the gerbil wheel 3D free orbit. Step 1 is to make a box. It might be easier if I start on 0, 0, 0, but I'd like to keep the icon intact without obstruction. So I'll pick a random point, pick length, because I don't know what the opposite cube is without typing the old-fashioned relative coordinates. I'll type length, line up the polar tracking angle to exactly 0 degrees. We want the top board of our sawhorse to be 36 inches. So for the length in the X direction, I'll type 36 and hit enter. By the way, length is always, always X direction. Width is always, always Y direction. I'll type 1.5, the cut finished width of a 2x4. And the height of a cut 2x4 is always 3.5, not 4. It's 3 points. They lose a 1/2 inch after the kerf of the blade and the finish sanding. So it's 1.5 by 3.5 is the real dimensions of a 2x4. I'll hit enter, and there is my 2x4 that is 36 inches long. Let me do an ID for good measure. ID, what happened? ID, enter. This point should be on the z=0 axis. It is. Hit enter. This point should also be on the z, not z-axis, but z=0 elevation. So the bottom edge of this 2x4 is lying flat on the floor being the XY plane. So there's our first step. I'll do a 3D free orbit to get the warm and fuzzy, lining up the XY plane. You can see that the board is perfectly on the floor, assuming the floor is the XY plane. Okay, I'll hit escape to bail out of 3D free orbit. I want the top surface of this board to be 36 inches high, but I want this board to be intact so I can stretch it or copy and union it into a 48-foot board, because the legs are going to have to be longer than the top board is high off the floor, because the legs are diagonal. So they got to be longer than the height of the board at the top. Okay, so I'm going to launch a line command. Start here at the z=0 corner. Double checking I got +0, not the 45-degree polar tracking angle, which I've turned off anyway. I'm going to set 36 degrees. I'm sorry, 36 units. AutoCAD unit represents an inch in this case. Okay, I'll copy this board so that these four corners are at the z=36 elevation. Okay, I'm on the 3D modeling workspace. So bear with me, I'm not quite as used to where icons are. I'll click copy, I'll select the board, I'll hit enter. I'll grab the copy from its original spot and snap it to the z=36 point on this vertical line. Hit enter. Now to double check, I'll type ID enter. And I'll snap. Yep, z=36. Enter, enter. Whoop, enter again. Object snap at the end point. z=36. Good. Both ends of this 2x4 are at a z=36 coordinate. Straight up from the origin. I'll 3D free orbit to get the warm and fuzzy. Looking straight down the z-axis. XY. Here is a plan view. I'm looking straight down at the XY plane, straight down the z-axis, and you can see both boards are going straight across in the 0-degree direction. Let me return it back to the pseudo southwest isometric. Being careful not to place the z-axis in the vertical direction, which causes a lot of confusion. I'll hit escape to get out of 3D free orbit. Now eventually the legs need to be longer than the height is, because the legs will be at a diagonal. And of course the hypotenuse is longer than the leg here. So I suppose I could stretch it out with press pull, but I've been using copy all these years. I've been using this exercise, so I'll copy it, I'll polar track in the 0-degree direction and type 12, enter, and that'll make the combined original plus the copy 48 inches long. Again, the original was 36, and I placed a copy 12 units or 12 inches down the X direction, or X polar tracking angle. Okay, hit escape. I'll union, U-N-I-O-N, if you don't, not accustomed to the icon, type U-N-I-O-N. I'll click the union icon, I'll select both and hit enter. And now this board at the bottom here is 48 inches. Do an ID again, hit escape, bail out, ID, enter. Down here is Z equals 0. The X and Y is about 2 by 4.5, roughly, because I didn't build it out perfectly on the origin. The coordinates at the other end here should be the same Y and 48 plus the X, and a Z equals 3.5. I've already forgotten the original coordinates, but I'll type ID, enter, click either one of these points, and sure enough, it's Z equals 3.5. Looking good. I'll do a 3D free orbit. Get the warm and fuzzy, line up the X and Y axes, so I'm looking right down the looking right across the XY plane as if I'm lying on the ground, assuming the ground is the XY plane. And yep, everything's looking good. This board is 36 inches high at the top and directly above my 48-inch board. Now the hard part. I'm going to align this 48-inch board with this 36-inch board so that the 48-inch board comes down at an angle, touches the floor at 12 inches from that corner there. I still need to draw the 12-inch chalk line, but it'll penetrate the floor right at 12 inches from that vertical line and continue on a few inches. 48 inches is more than enough to reach the deck, reach the floor at that angle, whatever that angle is. Now, I suppose I could line it up so that the board sticks straight out and continues at the Z equals 36 elevation and then swing it down. But the handout calls to use the align command, not the 3D align, but the old align command to do it all in one step. The new 3D align command that Autodesk puts on the top of the modified panel is not intuitive. So I highly, highly recommend drop down the modify panel and use the old align command. It looks perfect, it works perfect in 3D. It says right there on the description. Align objects with other objects in 2D and 3D. So click the align command. Now we're going to attach 3 bungee cords to this board here to points on the board and on the XY plane. I forgot to draw the 12-inch chalk line at the bottom. I'm sorry, bail out, hit escape. Line, I'll start at the end point of that vertical chalk line. I'll polar track in the negative Y direction, polar tracking angle. It says angle is 270 degrees, so it's straight down toward the negative Y coordinates. I'll type 12 and hit enter. So there's a chalk line on the deck or floor. I'll 3D orbit, double check. Yep, everything is lined up with the XY plane. That 12-inch line is on the XY plane, also known as the floor. Now, how can I change the color? Yeah, I'll do without. No, use regular lines. I want this point right here of that 48-inch 2x4 to perfectly line up with that point there, which happens to coincide with that 36-inch chalk line I drew earlier to raise up the 2x4. Now this, I hit escape. Now this point on the 48-inch board, I want to attach to approximately right here on the board, on the 36-inch horizontal board at the top. Notice it's homing in on the end point. Well, I can't rig a O-snap to be 36 inches, 33.5 inches off of the end point. So the second bungee cord will try to get that corner here as close as it possibly can to the midpoint. Okay, there, that midpoint. Now those 2 points alone would arrange this 2x4 to stick straight out horizontally, being perfectly level with the top of this 36-inch elevation, 36-inch long board. However, at the same time, I want this point to be as close as possible to this guideline end. Remember, the first bungee cord from there to there is infinitely strong. It'll shrink down to 0 when released the final enter. Bungee cord from here to some point along this line, midpoint is convenient. It's slightly weaker. And the bungee cord from this point to the end of this line is slightly weaker than the second, which is slightly weaker than the third. So all 3 bungee cords, the first is infinitely strong, second is weaker, third is weaker. We'll swing this 48-inch 2x4 around so that this point right here will coincide with that point. The point 3.5 inches above will coincide as close as possible to the midpoint, so it'll strike about right here, 3.5 units toward the midpoint from the corner. And this point will be as close as possible to this point, which will force the angle of the board to go through that point and slightly further through the XY plane or into the floor. Okay. Let me double check. We copied that. We made the 48-inch board. We made the 12-inch guideline on the XY plane. Use a line to bungee cord the 48-inch board into position for the leg. Notice that this point is as close as possible to the end of that 12-inch line on the deck, on the XY plane, on the floor. Okay, let's go back to our blank new drawing. Again, the 3D align icon is not intuitive. I don't recommend it. Drop down and use the old original align icon, which is good for 3D. Click on the align icon. Select our 2x4. It's 48 inches long. I'll select it again just for the sake of the video. Got one item selected. Hit enter. Again, bungee cord number 1 will hook onto this point. Being infinitely strong, it'll draw that point of the 48-inch board perfectly to this point of the 36-inch board when it compresses to 0 length. So the bungee cord will make that point coincide with this point. Click. Take the top corner directly above the first bungee cord hook number 1 point. I just clicked on the 48-inch board. And I want that, ideally, I want it to be up here in the 3.5 inches from the end. But again, there's no O snap that says, hey, snap from the end of the board 3.5 inches. So the next best thing is to guide it as close as possible to the midpoint. Remember, if you don't scale, change the overall size of the 48-inch 2x4, then all dimensions of the 48 2x4 will remain the same. So there is bungee cord 2, hook number 2. Click. Now that, notice any alternation of your display will eliminate the virtual bungee cords. I want this corner, which will be directly below this corner, if the 2x4 went vertical. I want this corner to penetrate the XY plane of the floor. Click at this point. So there's the third bungee cord, which is the weakest of the 3. Watch what happens when I click. This is still a bungee cord, and I'll tweak the display and you'll see it's disappeared. There, it's disappeared. Okay. Again, it might be easier to rotate this board and move it vertical so it sticks straight out horizontal from, parallel to the ground, and then swing it with the align command so that this point here is as close as possible as it can get to there. It might be more intuitive for students. Okay, let's look back at the handout, which again is pretty old. We finished this 1, 2, 3, 4, 5 steps here. Step 6 says use 3 points. O snaps. Why did I say O snaps? O snaps have nothing to do with it. Use 3 points to slice the leg at each end. Oh, the O snaps are to slice it at the top end. That makes sense. Slice it at the bottom, just pick 3 points in open space that are at Z equals 0. Be very, very, very careful not to creep up the Z axis. Okay, use 3 points to slice the leg at each end. Okay, we'll go back to our new drawing. We'll launch the slice command. Here's the release 2020, and I got 2022. Both new releases make it a little sandwich instead of a knife cutting a loaf of bread, like older releases did. Or you could always type the word slice, enter. We'll click the slice icon. Click. It says select what you want to slice. I really should have this command area larger. I'll select this 48-inch long diagonal board and hit enter. Now there's a variety of ways I can slice it. I've had extremely good luck with 3 points method, which is the default. The hard part is remembering to hit enter to agree with the default. So click 3 points or simply hit enter to agree with the default. I'll hit enter to agree with the 3 points default. Now I need to specify 3 points on the XY plane. Could be 0, 0, 0, could be 0, 1, 0, could be 158, comma 0, comma 0. Any 3 points on the XY plane. I'm going to pick 3 points at random, being very careful I never see the Z polar tracking angle up here. So that's asking for specify first point. I'll click over here to be very careful I don't go up the z-axis. Click again. And I'll click over here, being very careful I don't go up the z-axis. So all three of these random points in space are going to be on the XY plane. So the infinite guillotine blade that'll slice everything in every direction that's selected, that is, will cut everything off at the XY plane. Click. Last step says which side you want to save. I know I want to save the top, but I like to have my decisions and decide individually instead of having anybody else, even the computer, do things for me. I'll hit enter to accept both. There's the slice right at the z=0 XY plane. I'll do an ID enter. ID enter, and O snap at the slice, and sure enough, it's z=0. So that little space right there between these two pieces is the XY plane or the floor. Okay, let me enlarge this, rats. I don't know why these command areas get so finicky and I can't resize them. I'll leave it as it is. I need to erase this bottom piece then, since I left both pieces intact by hitting enter to allow both pieces to exist. I'll click the erase icon or e-enter or erase enter, and erase this part that penetrates below the floor. Everything down here is z=negative something. This is all below the z=0 plane. Hit enter. Oh, I need to slice this little doorstop wedge that's superimposed between both of these 2x4s. Well, to slice this little doorstop wedge here, I need to slice this 48 or this diagonal leg, no longer 48, but this diagonal leg. I need to slice at any 3 points on this face of this 2x4. Okay, any point along this edge, any point along this edge, and any point along this edge. The only condition is the 3 points can't form a straight line. Okay, so I'll launch the slice command again, or type SLICE enter. Slice command says, hey, what do you want to slice? I want to slice this diagonal leg. Select it with a crossing window, hit enter. 3 points is the suggested method of slicing, which I highly recommend. You can do anything, almost anything with it, except the slice in the view, which is rare. I'll hit enter to agree I want to slice with a 3-point plane. AutoCAD says, okay, we're going to slice with a 3-point plane, specify the first point of the plane. And then they'll ask the second point of the plane, and then they'll ask for the third point of the plane. 3 points of the plane will define the guillotine that'll spin around and cut everything off that you select. First point, I'll say right there. Second point, I'll say right there. Third point, I'll say, that's good. It could be there. Could be either of these endpoints, just so 3 points somewhere along the surface of this 2x4. I'll go right here, got a good clear shot. It's not too hard. Click. Got that command prompt or information line saying specify the point on desired side or keep both sides, with both being the default. Well, as usual, oops, I'm slicing up here. I want to keep both and manually erase it myself later. So I'll hit enter or click both to have both pieces. I'll hit enter, and sure enough, there's the slice. And this piece here that I'm flashing by sliding my cursor over, that is the scrap metal, scrap lumber. I can't think of a use for it in this project. I wish I could, because I hate to waste anything. So I'll hit the erase icon and select this severed, sliced off doorstop and hit enter. So now we got a beveled edge at the top. We'll cut the bottom level with the XY plane. And sure enough, I lost my navigation bar. Always something. Click view, click navigation bar, and it still doesn't come up. Okay, there it is. It's a little higher than I expected it. We'll go to 3D free orbit, not orbit. I highly recommend free orbit because of those little round circles at the quadrants of the gerbil wheel. Free orbit. Line up our viewport so we're looking straight across the XY plane. Grab one of these and rotate it around. Everything is looking good. Just like we had expected. I'll alter my display, being careful that Z is not straight up. Hit escape to get out of 3D free orbit. Now, we got one diagonal leg from the top board at 36 elevation down to the XY plane or the floor. The leg on the other side is going to be a mirror copy of it. The regular old 2D mirror command will work perfectly if we O-snap at the midpoint there and then polar track on the XY plane. But let's use the 3D mirror command with a 3D mirroring or a 3-point 3D mirroring plane rather than cause confusion with the old 2-dimensional mirror command. If I were to create a virtual plane from that midpoint to that midpoint and to that midpoint, in other words, the plane perfectly rips this 2x4 in half, the two pieces that are 3.5 tall and 3/4 wide, then it would reflect this leg straight across that 3-point mirror to make the second diagonal leg from the near end. Okay, let's go to home, click 3D mirror, or mirror 3D, 3D mirror, mirror 3D. Okay, select objects. I want to reflect this guy. I selected it. I'll select it with a crossing window to be sure. Got only one item selected. Just the one leg. So that's all I want. I'll hit enter. I definitely want to use a 3 points method like we did for the slice command. So I'll hit enter to accept the suggested 3 points default. Enter. Now it's going to ask me for the first point, then the second point, then the third point. They're all midpoints on these 1.5 long edges of this top board. There's the third point of the 3D mirror. Now it's asking, as always, do you want to delete the source objects, meaning the old objects that you just made mirror copies of? Very rarely do you say yes. I'll hit enter to answer this question with no. Zoom back out, and there's the original, and there's the new mirror copy. I think I can lose these two guidelines now. This was just a construction string set at 36 elevation to place the copy, just like you're building a cinder block wall. You place a stake and a string and indicate the top surface of the wall. This is the 12-inch chalk line, so that this point would be exactly 12 units from the corner there. The stance would be 12 and 12 and 1.5. It's the 25.5 inches from that corner to this corner. I have no idea what angle that forms, but it looks reasonable. Anyway, I'll erase those two chalk lines. Erase, select the vertical 36 and the 12 unit chalk line that points straight into the negative Y direction. We don't know how to create a UCS on this surface yet, which would make forming the triangular gusset plate, the diagonal support of these legs to keep them from spreading apart, easier. So I'm going to copy these legs and rotate them flat on the deck and then trace the V-shaped gusset plates as they contact the XY plane or the floor. Click copy, select them both, move them to the side. To be on the safe side, I'll type ID, enter, and every one of these points should be Z equals 0. Enter, 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 Z equals 0, good. All 4 points at the bottom of each of the legs is perfectly on the XY plane. And escape, I'll hit 3D rotate. I kind of like the old rotate 3D. I'm getting used to this. I'll click 3D rotate. Select both of these copies, hit enter. It asks for what base point do you want. I'll snap at any one of these 4 endpoints at the bottom of the leg closest to my face. Click. Now I want the green wedding ring to be the hand wheel at which I rotate this thing, having established a hinge right at that point. So I'll tap on the green wedding ring, making it gold. Now from experience, a positive angle I type will bring the top of this object straight down. You can also click start angle by going in the 0 direction and swing it straight into the 90-degree direction. There's 90 degrees, there it is. I think that's 90 degrees, or is it the Z? Anyway, I'm going to type 90 and it'll flop straight forward onto the deck. There, it's on the deck. Type ID, enter. Snap at any one of these points, Z equals 0. Enter, Z equals 0, Z equals 0. Yep, it is lying flat on the XY plane or on the floor. Don't believe me? All right, we'll stretch it, we'll line it up so we're looking at the end. I'll grab here and rotate, and you can see, yep, those legs are perfectly on the floor. Okay, let's use line. I'll trace this to form the gusset plate, there to there. Enter, enter, and there to there. That's about all I need. I'll erase the board since I got chalk lines on the XY plane or on the floor. Those are the lines I drew on the floor. How far from the top of the triangle gusset plate do I want the bottom? Say 12 inches, from top to bottom. All right, we'll offset. I don't know how, probably getting way off of this. You know, we're in step 8 here. We're assuming a 1/2 inch plywood. Trying to make this little triangle plate on the XY plane or on the floor. I don't see a dimension, but I've been in class, I've been using it 12 units from the top of the triangle to the bottom of the triangle. Let's go back to our drawing. Let's offset by 12 inches this piece in this direction. Well, that's way too short. Well, the extend command will shoot at both directions. I'll hit enter to finish the offset command. We'll click extend, which is a drop down from trim, or type EXTEND, enter. It asks for boundary edges. Surprised it doesn't say select all. I'll click boundary edges. There it says select all. I'll hit enter because I want to extend whatever I click to whatever it'll hit. I'll hit this end of the line. It'll extend in that direction till it hits something. I'll click on the other end and it'll extend in that direction until it hits something. You can take a look top down. Right there, it's almost looking straight down. We want to salvage this pseudo triangle piece here to extrude it into a sheet of plywood that'll nail onto the top of the diagonal legs. I'll hit escape. I'll click trim, drop down the extend, and click trim, hit cutting edges, hit enter for everything, and shave off the whiskers. This will be the, once we get it into a closed polyline or a region, we can extrude it straight up a ½ an inch. I'll hit enter to finish the trim command. I'll launch the join command rather than the p-edit command. Join is a step quicker. Click the join icon, and type J enter. I'll select all of these and hit enter. I'll select it. Notice the properties say it's a polyline and says it's closed. And that is one of the few objects that can be extruded. I'll hit escape to deselect. I'll click the extrude icon. I'll select my closed polyline, hit enter. Now it's asking for, hey, what height do you want to extrude it? Let's assume there's plenty of ½ inch plywood around. So I'll type 0.5 and hit enter to extrude it a ½ a unit. Now, how do we upright this and get it so we can nail it onto the top of the legs? Well, we can do the same as we did with the aligning the leg. We can align the plywood gusset plate. Right now, it's still on the XY plane. I just moved it there so I got short distances to O-snap. These 2 points to these two and this one to the bottom. Double check, I'll do ID enter, and all of these points, ID enter. Yep, Z equals 0.5. Why is that? Interesting. Oh, it's minus 0.5. Somehow I accidentally extruded it downward. So these top points are at Z equals 0. So this is the top surface of this gusset is on the XY plane, and I accidentally extruded it downward. Not sure how that happened. But in any case, I want to connect the bungee cord from there to there, being the infinitely strong one. The second one I want to connect, these are just regular lines. There's the second bungee cord, and the third bungee cord, I want to go from there to any point at the bottom here to flip the thing. So these 3 bungee cords, once released, will perfectly align the triangular plywood on the top of these 2 legs. Again, first one is infinitely strong, second one's a hair weaker, third one's a hair weaker. Let me erase these lines and use the exact same. There's 1, there's 2, there's 3. Okay, I'll erase 3 lines, launch the 2D old align command, or AL enter. Select the ½ inch thick plywood. Select objects. I'm done selecting objects. All I want is the one item found. I'll hit enter. Okay, bungee cord, hook one, bungee cord one, hook one. Bungee cord one, hook two. Specify second source point. Okay, bungee two, bungee cord two, hook one. Bungee cord two, hook two. Now, as soon as I alter my view, those two little virtual lines will disappear. But can't help that. The third bungee cord source point or hook one I want to put there. And I want to put it, there go the virtual lines. I want to put it as close as possible to any of these 4 points. This point is probably intuitive. Click. The triangle has been aligned. Told you. We'll drop down, get a virtual. For good measure, I'll do a 3D free orbit. Everything's looking good. And escape to lose the 3D free orbit. Now, the legs and the plywood on the far end of the sawhorse are a mirror copy of these. And again, I could use a 2D mirror command and any one of these endpoints, you know, draw a mirror line across the floor directly below these midpoints. But I'd like students to learn the 3-point mirror process. So let's exercise it again. Should we go to 2D wireframe? Yeah, that way we can see these 4 edges of the board, O-snap a little easier. And again, you know, check the conceptual or one of the higher end visual styles just so you get your bearings. Go back to 2D wireframe. Where's the 3D mirror? The mirror 3D. There it is, mirror 3D. We'll type mirror 3D or click the icon. I'll click the icon. Mirror 3D says select objects. I'm going to select these 3 objects with the crossing window here. The 2 legs and the plywood. That's all I want. Those 3 objects found. I'll hit enter. I want to use the 3 points method. Again, with 3 points, you can do any of these others with the exception of view, which is rarely used except for handouts for academia. The 3 points I'm going to be here, the three of the 4 midpoints here in the middle of the 2x4. There's the 4. Any 3 of them is sufficient to define the mirroring plane. Click, click, click. It says, do you want to delete the source? Rarely do you say yes. I'll hit enter to accept to say no. Da, 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 da. There, we're done. Let's do a hidden. Looks good. Do a conceptual. Do an X-ray. It looks good. Go back to their conceptual. I'll do a continuous orbit to get the warm and fuzzy that I've completed the assignment. It's not quite spinning on a vertical axis. Everything's looking good. I'm going to come around to where it was and hit escape. I believe we've got a winner. Yep, I lost my navigation bar again. View. Nope, not there. Click. Nope, not there. Click again. There it is. Check it. Oh, it's still in 3D free orbit. I'll hit escape. I tell students to save it because if we got time, we'll make a circle or an ellipse higher than this sawhorse, and we'll do a flyby animation. But that's low priority if we don't get around to it. That's about it. I hope that explains it better than the handout. I'll put this on YouTube in a second. Stop when we end the meeting. See you next time. Bye-bye.